Welcome back. This is the second part of the video series on 6.5. Now we'll be talking about the second type of the problems, solve the higher degree trigonometric equations. Let's start with the problem 6. Solve the equation 2x squared, not 2x squared, 2 cosine squared x minus 1 equals to 0 on 0 to 2 pi, again 2 pi excluded and 0 included. Now to solve this, we can see this is the second order, second degree equation, so we can expect there is at least two solutions. There might be more than one solution because this is a trigonometric function. So now to solve this, we can add 1 to both sides. 2 cosine squared x plus 1. I think I should write the minus 1 first. Minus 1, then we are adding 1 to both sides. So we get 2 cosine squared x equals to 1. And then we can divide both sides by 2. We get cosine squared x equals to 1/2. Now if we take the square root to the both sides, we get cosine x equals to plus minus 1 over root 2, which can be splitted as cosine x equals to positive 1 over root 2 and cosine x equals to negative 1 over root 2. Now if we look at the unit circle, cosine x is positive only in the first quadrant and the fourth quadrant. So when we consider the first case here, in this first case cosine x, the angle x could be either in the first quadrant or it could be in the second quadrant. So in that case we could write x equals to pi over 4. The first one, this is pi over 4, and to get the other angle here, we'll count how many pi by 4 we have traveled so far. So 1 pi by 4, 2 pi by 4. If I draw another line up here, 3 pi by 4, 4 pi by 4, 5, 6, 7. This is 7 pi over 4. So it's 7 pi over 4. Now if we take care of this, the second expression, cosine x equals to negative 1 over root 2. So this is negative, cosine function is negative only in quadrant 2 and quadrant 3. So the angle in the second quadrant is 1, 2, 3 pi by 4. So we can write x equals to 3 pi over 4, and to get the other angle 4, 5 or 5 pi over 4. So to write this general solution, we write the solution set S equals to, we start from the lower number, smallest number, to the largest number, pi over 4, 3 pi over 4, and 5 pi over 4, and finally 7 pi over 4. So this is the solution set, solutions to this problem, cosine squared x minus 1 equals to 0. Now let's solve one more problem, one or two more problems. Problem 7, 2 sine squared x plus 5 sine x plus 3 equals to 0. So at a first glance it looks like a polynomial equation, I mean quadratic equation. So if we substitute, let's say sine x equals to simply u, then if we rewrite the equation 2 sine x whole squared plus 5 sine x plus 3 equals 0, and then if we substitute this u back here, we get 2 u squared plus 5u plus 3 equals to 0. Then it is very usual form of a quadratic equation which can be solved very easily using factoring methods or many other methods. We already know that. So we can just write the factor like this: twice u plus 3 times u plus 1 equals to 0. And then, as we have learned in college algebra, we equate both of them equals to 0. So twice u plus 3 equals to 0, or u plus 1 equals to 0. So from here, if we substitute the value of u back here in this expression, we get 2 sine x plus 3 equals to 0, and if we subtract 3 from both sides, we get 2 sine x plus 3 minus 3 equals to 0 minus 3, or sine x equals to negative 3 over 2. Now if we look at this value, it is actually negative 1.5, and we know that the sine function for any values of x, for all real numbers, sine x is bounded between negative 1 to positive 1. So sine x cannot be equal to negative 1.5 or negative 3 over 2. So this value, this expression cannot be accepted. So we'll be taking care of this part only. So let's substitute u back again here. Sine x plus 1 equals to 0, which can be written as sine x equals to negative 1. And we know if we have the unit circle here, sine x equals to negative 1 is only possible at this position, and this is 1 pi by 2, 2 pi by 2, 3 pi by 2. Else everywhere we cannot get sine x equals to negative 1. So we have only one solution between on 0 to 2 pi. We have only one solution. By the way, we are looking for solution in this interval only for now. So we'll write x equals to 3 pi over 2. To write as a solution set, we should write s equals to 3 pi over 2, and that's it. Let's solve one more problem, then we'll end this video. For now, our next problem is problem 8. Cosine x times tan squared x minus 3 cosine x equals to 0. So we can see that in the left side we have one term common in both of these expressions here, cosine x. So we can factor out cosine x, and then we're left with tan squared x minus 3 equals to 0. The zero factor property, we can write either cosine x equals to 0 or tan squared x equals to, like, tan squared x minus 3 equals to 0. Then from the first part, cosine x equals to 0, if we look at the unit circle again, cosine x is 0 either pi by 2 or at 3 pi by 2 on 0 to 2 pi interval. We are always looking at the solutions on this interval 0 to 2 pi. So cosine x is 0 in pi by 2 and 3 pi by 2. So for this we can write x equals to pi over 2 comma 3 pi over 2. Now we work on the other expression, tan squared x equals to 3. We just added 3 on both sides, then we'll take the square root to the both sides, then I get tan x equals to plus minus square root of 3. Again we'll rewrite this expression. We'll split this tan x like this. Tan x equals to positive root 3 and tan x equals to negative root 3. Then again we'll take the help from the unit circle. So from the unit circle we know tan x could be positive root 3 at angle pi over 3. Here the coordinate is 1/2 comma square root 3 over 2. So the first element here, the first component of the order pair is cosine pi over 3, and the second component of the order pair is sine pi over 3. This is in the unit circle. So if I take the ratio of sine pi over 3 to the cosine pi over 3, I get root 3 over 2 over 1/2, and this 2 cancels, we get root 3. So this is our first angle where we get tan x equals to positive root 3. So and how about the other angle where we'll get again the positive root 3? So using the symmetry property we can write something like this, the other angle here. So pi, so we can write x equals to pi over 3 comma 4 pi over 3. I'm sorry, it's just it's not here actually, because tangent is negative in the second quadrant. So our next point would be in the third quadrant where tangent is positive. How this happens? Because in third quadrant this is negative 1/2 comma negative root 3 over 2, and the angle here all the way up here, this angle is 4 pi over 3. In degree measures it should be 240, I guess. Yeah, so in degree we can write this is 60 degrees and this is 240 degrees, although we don't need to write this in degree measures. Just to better understand, we can just think about this. Now let's talk about the negative part of the solutions. So the negative value, we can get the negative value at this point, the line that I drew before. Here the x coordinate is negative 1/2 and this is positive square root 3 over 2, and the angle here, this is 2 pi over 3. Let me write somewhere else. So x equals to 2 pi over 3, the first quadrant where we get tangent negative, and the other angle will be in the fourth quadrant somewhere here, and the measure of that coordinate will be 5 pi over 3. How did I get this value or this value? Well, if you initially know the first part pi over 3, we can easily get the other values. So to get this value 2 pi over 3, we subtract pi over 3 from pi. This is how we get this in the second quadrant. To get this 5 pi over 3, we subtract pi over 3 from 2 pi. 2 pi minus pi over 3. This results the angle in the fourth quadrant. Okay, so finally the solutions are s equals to pi over 3, then pi by 2. Pi by 2 comes from the first part, the other case. So pi by 2, then 2 pi by 3, then 4 pi over 3, and 3 pi by 2, and finally 5 pi over 3. That's how we solve this kind of problem. I hope this helps. Thank you for watching. See you in the next part.